In this video, we're going to talk about how to find the empirical formula of a compound from percent composition, and also how to get the molecular formula if we're given the molar mass. So let's start with this problem. A compound is composed of 52.14% carbon, 13.13% hydrogen, and 34.73% oxygen by mass. What is the empirical formula? Now let's say that we have 100 grams of compound. 52.14% of 100 grams is basically 52.14 grams. So that's how many grams of carbon we have out of a compound that's 100 grams. So that means that we have 13.13 grams of hydrogen and 34.73 grams of oxygen. So basically, when you're given the percent composition, simply make it grams. Base your compound out of 100 grams, and you could change the percentage into grams. Now, what you want to do next is you need to convert grams of carbon into moles. The atomic mass of carbon is 12.01 grams per mole. So you want to set it up this way so that the unit grams will cancel. And let me just get my calculator. So let's divide 52.14 by 12.01. So you should get 4.34 moles of carbon. Now let's do the same thing for hydrogen. The molar mass of hydrogen is 1.008 grams. So that means 1 mole of hydrogen has a mass of 1.008 grams. So let's take 13.13 and divide it by 1.008. So this will give us 13.026 moles of hydrogen. Lastly, we have oxygen, the molar mass of which is 16 grams per 1 mole. So 34.73 divided by 16, that's 2.171 moles. Now, what you need to do next is identify which number is the smallest. Clearly, it's the moles of oxygen. So what you need to do is divide every quantity that you have by the smallest of the three values. In this case, the moles of oxygen. Ideally, you want to get a whole number. 4.34 divided by 2.171, that is about 2. It's 1.999, but you want to round it to the nearest whole number if possible. 13.026 divided by 2.171 is 6. And this is clearly 1. So now we have the subscript for carbon, the subscript for hydrogen, and the subscript for oxygen. So the empirical formula, that is the formula with the lowest ratios, it's C2H6O1. So that's the empirical formula. That's how you could find it if you're given the percent composition of an element. So that's the answer for part A. Now let's move on to part B. If the molar mass of the compound is 138.204 grams per mole, what is the molecular formula? So we have the empirical formula. Now we need to find the molecular formula. The first thing we need to do is find the molar mass of the empirical formula. So there are 2 carbons, 6 hydrogens, and 1 oxygen. So it's 2 times 12.01 plus 6 times 1.008 plus 16. So the molar mass of C2H6O1 is 46.068. So now we need to know what empirical formula, or rather what molecular formula, corresponds to a molar mass of 138.204. So what you need to do is take the larger number and divide it by the small number. So if we divide 138.204 by 46.068, we are going to get 3. So if you multiply 46 by 3, you get 138. So therefore, to get the molecular formula, we need to multiply the subscripts of the empirical formula by 3. So this is going to give us C6H18O3. And that's how you find the molecular formula from the empirical formula. Basically, you got to divide the molar mass of the molecular formula by the molar mass of the empirical formula. Whatever number you get, multiply the subscripts of the empirical formula by that number, and that's going to give you the molecular formula. Number 2. A compound consists of 20.32 grams of carbon, 5.12 grams of hydrogen, and 7.9 grams of nitrogen. What is the empirical formula? So in the last example, we were given a percent composition, which we converted to grams anyway. Here we're given the grams of all the elements in this compound. So we're going to follow the same steps of converting each into moles. The molar mass of carbon is 12.01 grams for every 1 mole of carbon. So 20.32 divided by 12.01, that's 1.692 moles of carbon. So now let's turn our attention to hydrogen. The molar mass is 1.008 grams of hydrogen per 1 mole. And so this is going to be 5.079. And finally, let's move on to nitrogen. We have 7.9 grams of nitrogen, and the molar mass is 14.01. So this will give us 0.5639 moles of nitrogen. So now let's divide each number by the smallest of these 3 values. So the smallest is 0.5639. So 1.692 divided by 0.5639, that's about 3. 5.079 divided by 0.5639, that's 9. And this is going to be 1. So in the empirical formula, there should be 3 carbon atoms, 9 hydrogen atoms, 1 nitrogen atom. So the formula is going to be C3H9N1, or simply just N. So that's the empirical formula. Now, let's find the molecular formula. To do that, we got to find the molar mass of the empirical formula first. So we have 3 carbon atoms, 9 hydrogen atoms, 1 nitrogen atom. Now let's add up the numbers that we see here. So this adds up to 59.112. So that's the molar mass of the empirical formula. Now we need to find out the molecular formula that corresponds to 236.448. So what you want to do at this point is take the molar mass of the molecular formula and divide it by the molar mass of the empirical formula. 236.448 divided by 59.112, that's equal to 4. So therefore, we need to multiply the subscripts of the empirical formula by 4. So 3 times 4 is 12, 9 times 4 is 36, 1 times 4 is 4. So the formula is C12, H36, and 4. So that's the molecular formula. That's the answer for part B to this question. So now you know how to find the empirical formula and the molecular formula if you're given the percent composition by mass or if you're given the grams of all the elements in the compound. Thanks for watching.